Okay. So what we've been doing here is, since 2001, at the request of the Regional Park District, we've been looking at the structure of grassland communities. And the idea behind this project was to look at the spatial and temporal diversity of grasslands within the park system. And the idea for that is to develop the basis for designing a program that would help with monitoring of grasslands and also with develop a guide to some of the management aspects of grasslands in the Bay Area. So that project started in 2001. It ended in 2011, which is now. It's ending. And we've had permanent plots in 9 parks throughout the East Bay. We have a total of over 50 plots that we've sampled continuously for 10 years. We've gathered a lot of information about how these grassland systems in the East Bay work. My approach to, well, I have different approaches to range depending on my goals, but in one of my jobs as a scientist, my job is to ferret out scientific information, and I want to say right off the bat that the acknowledgement is that scientific information has some value, and it does because I know it has some value, but it doesn't solve all the management problems, and there are plenty of people that would argue that science can get in the way of solving management problems. I don't disagree with that science is a way of developing reliable knowledge about how things work, but it doesn't always answer the questions that managers need, where managers often need different kinds of information other than, that are not provided by science. But science does provide the basis for things like what sort of tools work and what doesn't work. But there's also been some interesting developments in what we know about how California grasslands work, and some of this has been pretty recent. I had a project funded by the Kearney Foundation in Soil Science that just was completed this summer, and this project was a project looking at biogenic silica in California grasslands. In that project, we found that we used a soil archive that Berkeley has, where there are 15,000 soil samples that were taken all over the state over the last 100 years. They took 155 samples of soil from grasslands in California. So these are places that now have grassland. They're taken throughout the state. And they looked in that, then they use those samples for a variety of purposes, but one of the things they looked at is the silica in these soils is produced as phytoliths, which are microfossils that are produced by grasses. And grasses have distinctive microfossils that get in the soil, stay there for hundreds, thousands, to even millions of years, and can later be identified as being produced by grasses. So if you think of this 155 samples, all taken in current grassland, of those 155, only 22 of the samples had enough grass-produced silica that we can say that those places prehistorically were grassland. This is an amazingly small amount. That means that less than 10% of what is now the grassland, think of the Central Valley, the Coast Ranges, all through there, go think of all of those places. The odds of a soil sample showing evidence that this was historically grassland is less than 1 in 10. But for a lot of these grasslands, they were not dominated by perennial grasses. What was there? Well, it could have been annual plants that were native. It could have been woody plants like shrubs. It could have been trees. And for a place like Vasco Caves, it could very well have been a shrub-dominated system. So we look at, why, what does grazing do and how do we develop grazing management plans? One of the main things that grazing can do is it can preserve grasslands. And so when you think about grazing for native perennial grasses, you have to think about grazing as an influence on protecting a grassland itself and avoiding invasion from these kinds of shrubs. So this result of very little evidence for these being grasslands a few thousand years ago is translated into something that if you like grasslands, especially let's say if you like the forages produced by grasslands or the recreational opportunities or the lower fuels that are produced by grasslands, then grazing can have an influence as a way in which that type conversion to a shrubby type can be can be prevented. The second thing is that in the course of this project, we have permanent plots that we've studied for 10 years now, and we've been able to separate out what the components of site, which would be soil and the local environment and annual weather patterns, from the effects of natural succession and from grazing influence. And for these grasslands, they're best described as what I'll call non-equilibrium systems. There are systems that are, and non-equilibrium doesn't mean they're unstable and disappear. It means that they're a system that's dominated by physical factors in the environment. And so on this and what we'll see next here is a really good example of that. Small scale patterns in soils, soil chemistry, and in topography, and also in the fluctuating weather patterns have a much greater influence on, well, everyone knows, especially the people that are living off of this, that the amount of grass that you get fluctuates tremendously from year to year because of annual weather patterns. Well, the composition also fluctuates. And so that's something we've known for a long time. But we've also found, because we have these plots permanently located, that there's an interaction between the specific site and the weather where it's worse than you might think, because the weather is influencing what kind of species you have and how much production you have, but it's different on different sites. So just knowing that there's a difference, you still got to know what kind of soil type you have, the details of soil chemistry, and unfortunately, this pattern is smaller, is of a smaller scale than the soil mapping unit. So here, most of the soil we're on here is mapped as Altamont clay. So that's a clay range site. It's a large soil mapping unit, but within that there are huge differences in things like soil phosphorus and soil carbon, soil texture, that have an influence on what you get on that specific spot. So those are two things that I wanted to start off with. They're cautionary things.